All right, so we're starting chapter 9, which is called rational functions. And yesterday you guys wrote down that if it is a rational number, it can be expressed as a fraction, okay, where both the numerator and denominator are integers, but the denominator can't be equal to 0. And we're going to simplify these expressions and state when the original is undefined. So for this one, sorry, video people, we already did that. We reduced it, okay, and then we subtracted. You guys did a nice job there. And then I asked you to factor this, okay? So this 3x plus 4, when you're dividing, there is parentheses around the numerator and around the denominator. So you can't just cancel out like a 3x and a 3x, but you can cancel out factors. So you can cancel out 3x plus 4 divided by 3x plus 4. Because when you divide something by itself, what are you left with? 1, right? Anything divided by itself is 1. Okay, so then this becomes a 1 in the numerator. This becomes a 1 as well, but 1 times anything is that same thing. You can leave it like this, or if you want the parentheses as a reminder that you cannot cross those out, okay, you can put the parentheses on them. Okay, so you cannot cross those out because there are parentheses around the numerator and the denominator. Okay, and then I asked you to factor part C as well. Okay, so when you're factoring 2, they already factored the numerator. So because this is a 6, I would start off with 3x and 2x because I can see that I'm probably going to cancel one of those out. Okay, and then we're guessing and checking with FOIL. Okay, so this is why we practice all that factoring beforehand. So when we get to something like this, it's a little bit simpler. We're not as focused on the act of factoring as we're going to be when we're multiplying and dividing. Okay, so I'm just rewriting the denominator as the factorization, and now I'm going to cancel. So if you have a factor divided by a factor, that will cancel out. So we have 2x plus 1 divided by 2x minus 3. Okay, now when you do the second part, when you state where something is undefined, you just take the denominator, and it has to be the original denominator, and you set that equal to 0. So for this one, the original denominator is 6x to the 4 equals 0. Okay, we can solve that in just a couple seconds, right? If you have x to the 4th, we take the 4th root. Okay, so then the denominator cannot be 0. That would make that a 0. Okay, so then all we have to say is this is where x cannot be 0. Okay, so that would go with your solution. Okay, so yesterday you guys wrote down, state when the original expression is undefined. That's when the denominator equals 0 because you can't divide by 0. Okay, so for B, when we take the original denominator, you can take the factored form because that's going to be a lot simpler to solve, right? So 3x plus 4 equals 0, x minus 1 equals 0. Okay, and I'm fine if you go right to that to jump to say it can't be negative 4/3. Subtract 4, divide by 3. And this one you could just jump and say x can't be what? 1. Okay, so then you can just say where x can't be negative 4/3. And if you just want to write a comma, you can, or you can write them both. All right, so I want you to do that for part C. All right, so then if you set each of those equal to 0, you get x can't be negative 2/3, and x cannot be 3/2. How do we do? You guys with me on that? Okay. So the reason why it can't be those is because if you plugged it in, the denominator would be what? 0, and you can't divide by 0. Okay? All right. Now, for part D, the numerator is a binomial. You might want to write this in standard form first. That isn't a requirement, but sometimes that can help. So by standard form, I mean the x squared would go first, plus the 4x. And then on the bottom, you factored the trinomial, hopefully. You had x and x, a -4 and a +2. Okay, and then we're going to factor the binomial together. So if you have a binomial, you want to look for the GCF, so the greatest common factor. In this case, it's a variable. What can we take out? X, great. Now, if you take out an x, this would be -x plus 4. Instead, let's take out a -x and see what happens. So I want you to write what goes in the parentheses when you divide by -x. And see if you can notice why we did that. So when you factor something out, you are just dividing. So -x² divided by -x is x. 4x divided by -x is -4. Okay, and the reason why we took out the -x is so that now we can do what? We can cancel out what? Yeah, now we can cancel out the x minus 4s. So we are going to practice looking at when you need to take out the negative, because that can happen sometimes. So -x is left in the numerator. X plus 2 is left in the denominator. Okay, and this is where x can't be. So again, you always just take these two and set them equal to 0. Right? If you set that equal to 0, x can't be 4 or -2. So that doesn't have to be something that's a super long process, right? You just see what's on the denominator, solve for 0. Okay, now for E, we had a trinomial here. Did you guys have time to factor that one? Okay, so this is prime, so it's 2b and b. To be or not to be is what that sounded like. Okay, so you have 2b minus 1 and then b minus 3. Okay, now in the numerator, this is a binomial. Do you guys remember something special about this? Yeah, it's the difference of two squares. Nice. So when we factor that, usually we're used to the variable being in front, but it's okay that the 9's in front. What's the square root of 9? 3, so it starts with 3 and 3, and then one has to be minus a b, one has to be plus a b. Okay, and remember, when you are factoring, you can always guess and check with FOIL. So 3 times 3 is 9, -3b, +3b, makes 0, and then a negative times a positive will be -b squared. Okay, now be careful here because b minus 3, yep, we can cancel out the b's. See how you have b minus 3, and this is 3 minus b. So they're almost the same, but look in front of the b. This one's negative, this one's positive. So what should we do here? Can't cancel it out yet. Yeah, take out that negative. Okay, so if you take out the negative, this becomes a -3. So I'm going to write that second, and then I'm going to write the b first. Okay, it might take you a second to wrap your mind around that. All I did is pulled out the negative. So if you were to redistribute it, you have -b, +3. But the reason why we do something like that is now we can, bless you, now we can cancel. Okay, so now we can cancel out the b minus 3 and the b minus 3. And then if you have, bless you, if you have b squared over b, what happens there? B cancels out with one of the b's. Yeah, subtract the exponents, exactly. All right, so sometimes there's a lot of stuff to keep track of. I could have wrote out another step here, but this negative has to stay in front. Now I have 1b, and then sometimes I cross that off too. You can keep this as 3 plus b, or if you want to write it as b plus 3, either way is fine. I like writing those in standard form. Okay, so you have negative b times b plus 3 over 3 times 2b minus 1. Okay, and that's going to be your final answer. And then we just have to find where our restrictions are for b. Okay, so one thing I like to do is I like to look at this factored form. I have this 3b. This whole thing is the denominator, right? So if I were to set that equal to 0, don't forget about this guy. 3b is 0, 2b minus 1 is 0, b minus 3 is 0. Okay, so based on that, I want you to list the 3 restrictions for b. There's 3 numbers it cannot be. Yes, minus 13. Okay, and then when you divide by 3, you'll get 0, so b cannot be 0. Okay, add 1, divide by 2, 1/2 is a restriction, and 3 is a restriction. All right, any questions on those? All right, so for f, okay, you have x, and then we have a trinomial. Okay, so if it's x squared, you're going to start with x and x. Has to multiply to negative 15, add to 2. That's light work for us, right? Okay, now in the denominator, you have the 4x plus 20. You can factor something out. What can you factor out there? 4. Okay, so the GCFs do have to get taken out. And then x cubed minus 9x, what can I take out there? X. So it's x squared minus 9. Oh, x squared minus 9 can be and we're going to organize everything once we factored it, okay, because it is a lot easier to keep track of. Yeah, the copy machine, one of our copy machines keeps doing that. I know. That's why when I printed the test, I'm trying to use that one copy machine. But I don't like it because sometimes it goes through something that I want. I know, yeah. But hopefully that toner will be out soon. Like the toner line. Like the printer line. No. All right, and then x plus 3x minus 3. So when you're crossing things out, like I like to be methodical so I don't miss anything, or else my mind goes 100 places. So I start at the top, so x, and I see if there's another x to cancel out with. If there is, I cancel it. Then I go to x plus 5. Yep, I can cancel it. X minus 3. Yep, I cancel it. Now, if you cancel everything, that just becomes 1. So you have 1 in the numerator. Now, in the denominator, you're going to keep it like this. Okay, and I guess I should have wrote that on the one before, but this is factored form. Okay, so factored form, you always want to make sure there's no GCF left there. So don't write 4x plus 12. Keep those GCFs out. Okay. Okay, so for this denominator, you have 4x equals 0, x plus 5, x minus 3, x minus 3. Okay, so let's write what x's can't be. Okay, so x can't be, this one is going to be what restriction? 0. Okay, this one will be -5. This one, -3, and the last one, 3. 3. I'm laughing because I just graded all these tests, and there's times where I'm having the same thing. I'm like, what number is this supposed to be? No.
How much did we do?
I don't know. I was probably insane when I made this thing. This morning I was like, man, I need to let them figure some things out on their own. Like, I don't have to show you everything.
No one said that. Who said that?
Well, okay, like this one, I feel like you guys could do this one on your own.
Yeah, but we don't want
What?
I mean, we could, but after you show us out,
Oh.
don't have any more.
All right, we'll do it really quick. Okay, so 4 minus x squared, 2 minus x, 2 plus x.
I don't have any room. I just don't have room.
You guys need a post-it?
Is there a back page? Like this back page.
Can I buy?
Like there's a back page.
All right, so this one is just -4 and -4. And this is just x minus 4 and x minus 2. Yeah, so in my mind, you were just going to come in and we're just going to cancel all these out.
Oh my god.
I know. Actually, after you guys do the homework, maybe I'll pick a few of you to be my ambassadors and you can tell me which ones I can get rid of for next year. No. Okay, so all right, so when you're going through, if you don't, this is 2 minus x, this is positive, so you can come back to that, 2 plus x, x plus 2, x minus 4, x minus 4, okay, this one's got to stay. It may take you writing it out again to notice this, but if the signs are flipped, that just means you're going to take out the negative. Okay, so if the signs are flipped, you're just going to take out the negative. Okay, and then you can cancel those out. See, I just feel like we'd already seen that, but maybe I wanted you to see one with a negative in front. I could just say that. Or I could just like use this for a warm-up the next day, you think?
Yeah. Could make like another one.
All right. Okay, the next thing we're going to do is multiplying and dividing. Well, on the next page.
We're doing all 3 pages today right now.
No, we're not going to do the last page.
One page a day, right? It's like a
Yeah, the answer is negative x minus 4 over 2x. I know. We can do this. In fact, I'll let you guys do some of this on your own, so that way you're not just listening to me, which I know gets boring. No, because then you're not thinking.
I wasn't thinking about it.
What? All right, so when you are simplifying here, it will have the direction simplify, but you really are just going to be multiplying and dividing. Maybe I'll have you guys do B as a warm-up tomorrow, and we'll just do A, C, D, E, F, G, H, I. I know. But no.
Maybe we just relax and let
No.
We just remove this lesson. Maybe we just grab
we should go down
one favor for cleaning.
Maybe let's just cook and stop complaining.
and then to the gym and take a walk.
Ooh,
What are all these birds?
I know. There's a lot.
I'm just
Such Debbie Downer.
I know. We gotta stay positive. I know we're tired. I'm more tired than you are because I had to do this already today.
You guys divided?
Yeah.
Oh no. What
All
did
right,
third hour
so-
say about this?
They were quiet, but then they were overwhelmed, and as soon as I stopped talking, they all were freaking out.
I thought the 16 hours long and I got
I did kind of.
No, every time we get my time to class, I just know if someone asks if they have to be listening to this song.
Yeah,
They're probably listening on 2 times speed.
They can be like, oh, I know Heidi's
actually,
All right, so a few things. These consist of skills you already have. Okay, so you know that when you multiply fractions, you multiply straight across. You do the numerator times the numerator. You do the denominator times the denominator. And when you are multiplying with the same base, what do we do to the exponents? Add them. Yep, so you're going to add your exponents. Okay, so that rule is a to the m times a to the n means that you are going to add them together. Okay, that's something we did this year. It's also something that you've done in Algebra 1. So you can decide, you can multiply everything straight across, or in the next one, I'll show you another strategy you can use. So what I do is I make a big fraction, and there's more than one way to do this. You're going to find what works for you. When you are multiplying across, the 3 times 10 is going to be 30. X to the 5th times x to the 3rd is going to be x to the what? Good. And then y to the 7th. Okay, so we're adding those together. 2 times 9, 18. Go ahead and do your x and your y. Okay, and then remember you're adding. So x cubed, x squared is x to the 5th, and then y to the 12th. Okay, from here, we're just going to reduce the fraction. So 30 over 18 is going to, what's the largest number that goes in a bowl? 6. So if you divide by 6, you get 5. If you divide this by 6, you get 3. You can divide by 2. You can divide by 3. Just you might have to reduce a few times, and that's fine as well. And then when you are dividing, if you have a fraction and the same base, what do you do with the exponents? You subtract. Okay, so 8 minus 5 is 3. So the rule is if it's positive, it's going to go on top. Okay, yep, and you make it positive. So 7 minus 12 is negative 5. So to make it positive, we put it on the bottom of a fraction, just like before we were putting it under 1. Okay, and a good way to think about that too is the variable is going to end up wherever the higher exponent is. So 8 is on top, so x ends up on the top. 7 and 12, 12 is on the bottom, y ends up on the bottom. You can also think of it like this. 1, 2, 3, 4, 5, 6. You know what comes after that? Oh man, 12.
You guys put the denominator for this one too.
No, I did this with the other one, but then we weren't going to do that today, so now I'm just showing you the visual. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so all I want to show you is that this is why it ends up on the bottom. When you cancel these out, okay, do you see how you have 5 y's left on the bottom? Okay, that's why. Okay? All right. Now, we know that when you're dividing, are you guys keep, change, flip people?
What's the other alternative?
Multiply by the reciprocal? Or if you are a millennial like Miss Whipple, we would say skip, flip, multiply. So you skip the first one, you flip the second one, and then you multiply across.
Oh, is there any hidden
Just me. Did you say you thought I was a baby boomer?
Which one would even pass for like the next?
Miss Whipple, what was the Great Depression like? All right, so when it is division, okay, when you see this in your textbook, the first thing I like to write out on my paper is the multiplication. So when you do the flip, the 16y to the 5th goes in the numerator with z. Okay, so we're going to keep, we're going to change, we're going to flip. Now, in part A, when we multiplied across, it was just 3 times 10 and 2 times 9. So that was not a lot of mental energy. We could still multiply these across, but remember, whatever's in the numerator is being divided by what's in the denominator. So you can simplify if you want before you start multiplying. So see how you have 16 over 8? What's 16 divided by 8? 2. Okay, it's like 2 over 1. It's a ratio. You're dividing them both by 8. And you could even simplify this one. So 5 over 15 is? Okay, so if you divide 5 by itself, you get 1. If you divide 15, you get 3. Okay, and then I like to multiply across. So 1 times 2. Yep, and then I try to keep them in alphabetical order. You can also just do that at the end. So I have x to the 4th, y to the 5th, and how many z's do we have? 4. Yep. Yeah, when I make my z's, I will put a line through it so you don't get confused with the 2. Okay, and then on the bottom, number by number, so 1 times 3, x and x, y and no other y, z, and then there's this random c, and this happens in your homework, which is why I wanted you to have one like that. Okay, now we're ready for the division. Okay, so again, I just start by making that fraction bar. Reduce numbers if you need to. Ours are already reduced. And then x to the 4 over x to the 5th. So how many x's do I have? 1, and it goes?
On the bottom.
Yes. Okay, and then y's, how many? 3 on the top. Z's? 3 on the top, and then c squared on the bottom. Okay, and I'm fine if you leave it like this. You can also write it in alphabetical order, but sometimes just there's a random variable from the beginning of the alphabet mixed with the ones from the end of the alphabet. So either one of those are fine. Variable.
How many more do we have?
3. We got this. No, we're not going to do the back page today. Okay, so x squared minus 4. You're manifesting doing the back page. Okay, so x to the 4 plus 2x cubed minus 8x squared over. Okay, so when you see a problem like this, when you write it down from your book, if you want to start factoring it right away, you can. Okay, if it's on a worksheet, you can start factoring above. So if it's a binomial, we're always checking for that GCF first. So the x squared is going to come out. You have a trinomial, so we'll factor here. Okay, so if you take out x squared, you get x squared minus 9. We'll factor that down in the next step. And some of the factoring problems are pretty quick. So when you have a prime number and a prime number, just remember if it multiplies to a positive and adds to a negative, they both have to be negative. Okay, and we're going to change, and then we're going to end up flipping this. Okay, now in the numerator, what can you take out of all of those? X squared. So we're going to do that first, and then we'll factor in the next step. All right, so here we have x squared minus 9. We recognize that as the difference of two squares, so we factor that down. We've already factored the denominator. Okay, and then it will be times, and then we're just going to flip this. So the x plus 4 times x minus 4 is going to go on top. And then on the bottom, we have x squared, and then we're going to factor that trinomial. Trinomials that start with x squared are our favorite because we know how to start that, and then it just multiplies to negative 8, but adds to 2. Okay, and then once you have this times, all of this is in the numerator, all of this is in the denominator, and we can start canceling. And then when you cancel, just do 1 slash so I can still read what's underneath. So x squared and x squared, and then x plus 3, nothing to cancel. X minus 3, yes. X plus 4, yes. So there just has to be one on the top and one on the bottom. Once you went through the top, then there's nothing else you're going to be able to cancel out. And then we're going to leave this in factored form, which is less work, right? We don't want to FOIL that back out again. We're just going to leave this in factored form. All right, so I'm going to have you try part B. Don't be scared.
Well, I was just trying to finish up the last.
Okay, and I'm going to give you a hint that if there is a GCF, take that out first. It will make this easier. Okay, so if there's a GCF, take that out first. Oh, it's 8x squared minus 28x. I know, the 2 and the 8 I put. You can decide. So I would, you can factor it first and then do the keep, change, flip. You don't have to. I just feel like it's less writing for you. Yeah.
All right, got it. Thank you.
Mm-hmm. 4x squared minus 1? All right, so when you factor x squared minus 9, we're feeling good about that one? X plus 3, x minus 3. Okay, we weren't scared of this 2, were we? Because it's just a 2x because it's prime. And then it has to multiply to negative 4, add to negative 7. If we put the negative 4 here, when we guess and check, that becomes negative 8. And then plus 1, negative 7. Okay? This is also perfect square. So what does that factor into? Good. 2x plus 1, 2x minus 1. Now this one, 8, 28, 12. What should I do? Take out the 4, right? And then once you take out the 4, it's not going to be as large of a task as we first thought. Because now we can factor this down. And 2 is a prime number. So 2x and x. If this is a positive and this is negative, what do we know about the signs? Both are negative. Great. And then 3, the only thing that makes 3 is 3 and 1. So if I put the 3 here, that becomes negative 6 and then minus 1. Okay, and then I'm going to organize this so that I can cancel. So when I organize, I keep this the same. So I keep it as 2x plus 1 times x minus 4. And you guys are doing a nice job. I know it's a lot of writing today. Okay, so I changed that, and now I got to flip this. So the 2x plus 1 goes on the bottom. The 2x minus 1 is with it. And then don't forget this 4. Sometimes I'll write that in front so I don't forget it. And now we can do the cancellation. Okay, so when you cancel, you're going to have 2x plus 1, 2x plus 1. X minus 4 has nothing to cancel. 4, no numbers to simplify. 2x minus 1. So as long as it's 1 on the top and 1 on the bottom, you can divide. Okay, if they're both on the top, you can't cancel. All right, so what's left? I have a 4 and an x minus 4. I'm going to leave it in factored form, no GCFs. And then x plus 3, and if you want to leave it in parentheses, you can. Okay, sometimes that helps you from canceling things out that can't be canceled. Okay, so make sure, no GCF. Make sure you factor it out. Okay, now the last type you will see, you are manifesting page 3, so I don't want to hear it. Okay. All right, just one more, and you can see that it's different. So I wasn't crazy putting this on there. Yeah, what does the negative 1 mean? You're going to flip it. You're going to flip the fraction. Yeah, so if you have a negative 1, right? If you apply a negative power, let's just say we had 3 to the negative 1. To make that positive, it would be 1 over 3 to the first, right? If you have a fraction, then you would just move each one to the separate places. If you have a negative, it goes to the top. If you have that, it goes to the bottom. Okay, so that negative 1 exponent means that you are going to flip the fraction. I know. So much faster. How dare
I don't know. Hold on, let's say that.
I thought the first thing
you? We're not. Remember, it's our favorite F word is factory.
Wait, can't you just like not keep it with it? If it's negative?
Say it again.
Just not keep pinch flip it.
Yeah, so you're right. So you won't keep change flip it because this is times. Okay, so what you're gonna do is you're only gonna flip the fraction with the -1 on it. Okay, so when we flip it, I thought we'd factor it first so that we don't have to write that out again. So look, this is 2, 2, and 12. So let's make our factoring a little bit easier and take out that 2. So x squared plus x minus 6. Okay, so if we're flipping that fraction, this 2 is going to go on the bottom, and then let's factor the trinomial. So x squared means I'm going to start with x and x, multiplies to -6, adds to 1, so we have negative and positive, -2 and +3, yep, either, any order is fine. And then here, let's go ahead and factor that. We'll factor it here. So start with x and x, multiplies to -5, but adds to +4. So anytime the ending is negative, you know these have to be opposites. And 5 is prime. The only thing that multiplies to 5 is 5 and 1. So does 5 have to be positive or negative? Positive. Okay, and then it's times. Okay, let's take this out over here so that we can write less. So if we take out the 2, because that's a GCF, and what else? X. And when you take something out, you're just dividing. 2x cubed divided by 2x is just x squared. You can always do a quick check with the distributive property. -4, and then what does that break down to? X plus 2, x minus 2. Great. Okay, so you can see how a lot of the things that we've done this year are building, right? We're using exponent rules. We're using factoring. Okay, and then to make sure we don't miss anything, like I said, I always start here and I say, okay, does it have that? If yes, I cross it off. If not, I move on. Nothing to cancel. So this, the 2 and the 2 cancel. X plus 2, nope. X minus 2, yup. So I have this x, that's going to go in front. Doesn't matter what order you put these in. You can do x minus 1 and x plus 2. Okay, and then you have x plus 3, x minus 7. Okay, and then I'll have you guys write down these so that you can try that one. And then while you guys are working on that, I'll show you our schedule. I thought so too, but
Change her mind when the girl changes clothes. You say you change your mind when your girl changes clothes. Missy, what's that?
she said I can. Because what I'm thinking is you'll want more time to work on your homework tomorrow.
What? Homework? Homework that was only
So that one is time. So see what you can reduce there.